Hello everyone, I'm Ion and today I'm facing a real puzzle. My lab is full of gadgets, but I have no idea what they do.
Don't worry, Ion. Professor Electro is here to shed some light. We're going to become battery detectives and master these tools today. First up is the multimeter. It's the Swiss Army knife of electronics. We use it to check the resting voltage of a battery. Watch closely. Ion is connecting the red and black probes to the battery terminals. It shows 12.8 volts. That's a great start. But remember, voltage is just pressure. Think of this garden hose with a kink. There's pressure, but the water has no real muscle to flow.
Now, let's head to the garage. Sometimes batteries drain overnight for no reason. We call this a phantom draw. It's a real mystery. Professor Electro uses a DC clamp meter to detect these. He doesn't even need to disconnect any wires. He just clamps it around the cable.
The meter senses the invisible magnetic field. See that? It reads 0.05 amps. That's a tiny leak, like a dripping faucet. Next, we visit a professional battery shop. Here, they use Conductance Testers for quick checks. This tool sends a tiny frequency wave through the battery plates. It's like a sonar pings to check the internal health without draining it. This pings tells us 4 massive pieces of data instantly.
I thought it just said good or bad?
Knowledge is power, Ion. Let's break down the 4 pings it found. First state of charge, or SOC. This is just the voltage. Is the battery currently full or empty? Like a fuel gauge. Second is state of health, or SOH. This is the big one. It compares the battery's current ability to deliver power against its original factory rating, or CCA. Even if it's 100% full, its health might only be 40%. Third is CCA, or cold cranking amps. The actual punching power left in the battery to start your engine on a freezing morning. Lastly, internal resistance, the resistance to electric flow.
Wait, explain the internal resistance part. Why does that matter?
Imagine the battery plates are a highway. When a battery is new, the road is smooth and 8 lanes wide. Electricity zooms through effortlessly. But as the battery ages or suffers from sulfation, potholes and roadblocks form.
So the electricity gets stuck in traffic?
Exactly. That's internal resistance, measured in milliamps. The higher that number goes, the harder it is for power to get out.
So a low resistance means a go, and high resistance means a no-go?
Precisely. A professional shop uses this sonar to see the traffic jam before you're stranded in a parking lot.
But what if we really want to push the battery
into the load tester? It's heavy, rugged, and looks a bit like an old toaster. When we turn the knob, the carbon piles compresses and resistance decreases. This simulates the massive effort of starting a cold engine. The tension is rising. We have to hold this for 15 seconds. If the needle stays in the green, the battery is a champ. Finally, we have the deep cycle marathon. For batteries that power boats or RVs, we use a discharge cabinet to test endurance. While the load test was a sprint, this is a long-distance run. It measures how long a battery can provide steady power over hours. Great work, Detective Ion. You've learned about multimeters, clamp meters, conductance, and load tests. You're now a master of the tools.
Thanks for joining us. If you want to learn more about keeping your electronics healthy, follow us at Ionize. See you next time.